Hello, all, and welcome to Beyond Belief. My name is Adam Jacobs. It's a pleasure to be here as always this evening. And Beyond Belief is a show that brings together thinkers from different backgrounds, artists, scientists, academics, people who are striving together for meaning and integrity. That's our theme and that's our motto. And tonight is no exception. I'm very excited to have this conversation. And our guest this evening is named Bill Diamond. And he is a Silicon Valley technology veteran and current president and CEO of the SETI Institute in Mountain View, California. We're going to talk about that a lot tonight. Mr. Diamond has over 30 years experience in laser photonics and optical communications networks, X-ray imaging, and semiconductor processing technologies. His corporate background ranges from venture-backed startups to Fortune 100 multinationals, including CEO positions at Wave Splitter Technologies, Dense Light Semiconductors, and others. He holds a BA in physics from Holy Cross College and a master's in business administration from Georgetown. He is a member of the Optical Society of America, the International Astronomical Congress, and the American Association for the Advancement of Science, and many other things, by the way. Very impressive individual with a great resume. And without further ado, let's bring onto the show Bill Diamond.
Hello there.
Hi, how are you? Welcome.
Thank you very much. Wonderful to be here, and thank you for having me.
It's great to have you. And, you know, I think it's fair to say that very many people have a great fascination with what lies beyond. I think when I was even in nursery school, I remember they asked, what do you want to be when you grow up? And I put down astronaut. Now, of course, I don't think you could pay me all the money in the world to actually do that. But at the time, it was, what fascination and excitement and wonder that profession held. And I think, considering the volume of films and novels and just general societal excitement at the possibility of what lies beyond the stars, there is no more exciting endeavor, it seems to me. And you're, really sitting in the heart of all that. And I guess my first question is, could you explain to our audience what SETI does?
Sure. Well, the SETI Institute has been around for about 37 years. The word SETI is an acronym, and it stands for the Search for Extraterrestrial Intelligence, which causes some confusion at some point because if people refer to us as just SETI, we say, no, it's the SETI Institute, because SETI is an endeavor, we're an organization. But certainly our origins go back to actually a NASA program at the NASA Ames Research Center back in 1984. And NASA was at that time funding and undertaking the use of radio telescopes to search the heavens for signs of technology as a proxy for life and intelligence in the universe, which was based on ideas and theories that had been put forth by astronomers and scientists at Harvard and elsewhere as long ago as the late 50s and 1960. And then the Institute was established as a separate nonprofit and sort of spun out from NASA at that time because it was felt that the Institute could explore opportunities to do additional types of related research about the study of life in the universe, which is now a field of so-called astrobiology, and do so with a financial structure that was perhaps less expensive in terms of overhead costs and administrative costs than, say, academic institutions or even government institutions. And so that was gave birth to the Institute. And since that time, we have brought in scientists from all over the world and the United States, most of whom write research grant proposals, mostly but not exclusively to NASA. We also have funding from the National Science Foundation, from the Space Telescope Science Institute, from the U.S. Geological Survey, and other entities. Even the NIH is funding some of our research. But these scientists write proposals based on the kinds of research that these organizations want to get done. And if they get funded, they have a job and they do that work. And it covers a wide range of things, from astronomy and astrophysics to planetary science and geology, climate and environment studies, exoplanet research, a wide range of fields. And of course, also SETI, where still to this day we use radio telescopes, but now also optical telescopes to search for signs of technology beyond Earth, beyond our solar system, which would, if found, be rather definitive indications of life and intelligence beyond Earth.
Yeah, and I know that's what everyone is anxiously waiting for. And I want to ask you something about that in a few minutes, but how did you personally get interested in this? Seems like you have a tech background. You were in Silicon Valley. Was there some kind of pivot? Was there some moment that you said, I really just want to get involved with this search?
Well, it's really an interesting story. I mean, studying physics as an undergraduate, of course, one of the core programs in that curriculum is astronomy and astrophysics, which was my favorite. And I felt that, this was something I always felt was very, very exciting. I got involved in laser technology even while as an undergraduate. And I think I probably said to myself at that time, I don't think you're really smart enough to be an astronomer. So let's go somewhere else. But I always had a love and a passion for it. And of course, I grew up reading Arthur C. Clarke and watching Star Trek and just being fascinated by all things space, and watched the Apollo program and, the Mercury and Gemini programs before that. So I grew up in the space age and always had a love for it. But what happened with the SETI Institute, I was, in the photonics world at a company, helping basically provide the technology that is behind the internet that allows us to do the sorts of things we're doing today.
Thank you.
Yeah, right. A lot of people, more than me, get that credit. But in any case, that's what I had been doing. But I had left that company because they were going to be bought by a bigger company, and I wanted to do something, different. And a dear friend of mine that I had worked with at Bell Laboratories for many years was on the board of the SETI Institute, which is something I knew, and I just thought it was the coolest thing. And like you, I said, how did you get that gig? Because I was supposed to do something at the SETI Institute. Well, and lo and behold, he contacted me after I had left that company and said, we have some issues at the Institute. I'm on the board. Could you come and help us out if you've got some time? There's our headquarters here in Mountain.
I love your logo, by the way. It's so clever.
That has a wonderful story behind it too, which if you allow and we have time, I'll be happy to tell.
Tell. Yeah, I'd like to hear it.
In any case, so I came to help the Institute out with some difficult situations. And the long story short is that morphed into, would you consider staying and running the organization? And I said, where do I sign? It was, for me, an opportunity to shift from sort of applied engineering to pure science in a field that I felt was so compelling and fascinating. And, the opportunity to work with these people who really are smart, these scientists that we have here in so many different disciplines, and also to connect the dots between so many different disciplines. There's so much different kinds of science that come together to inform the work we do. It's just fascinating. It's like going to school every day and learning something new. I've not had as much fun I've been very happy and fortunate in my career and have no regrets, but I've never had more fun than I'm having now.
That is a great blessing.
It is.
Yes, to love what you're doing, and that's great. I was looking at your website, which I was very impressed by, and it came across one line, which says, while some people think that the extraterrestrials with their advanced technology may be able to come here, that this is not a popular idea amongst most scientists. And so I guess I'm inclined to ask you why, because I think that most of us lay people sort of expect that they would or could or should or something.
Sure.
But why do you guys feel that that's not in the cards?
I wouldn't necessarily say it's not in the cards, but what we would say about that is that any evidence to that effect is anecdotal at best and suggestive and indicative at best, but hardly definitive or something that can stand up to scientific rigor. And one of the tenets, I would say, of the research we do at the Institute is that extraordinary claims require extraordinary evidence.
Sure.
And if you have extraordinary claims with sort of superficial or rather unconvincing evidence, then you should be careful about making those claims. Of course, a lot of what you're saying relates to the phenomena of UFO that are absolutely fascinating. They capture the imagination of people. Why? Because I think people want to believe that we're not alone in the universe, myself included, and I'm convinced we're not. But like so many things over human history, we'll ascribe answers to puzzles that we have. Where did we come from? Where do we go after we die? What is that thing in the sky? We'll come up with an answer because not having an answer is too uncomfortable. But just because we come up with an answer doesn't mean it's the right one. So, for example, at the Institute, we have no doubt that there are these things that are unidentified flying objects. They are, as they are called, unidentified. We don't know what they are. We don't know necessarily how they work. But in any case, we also start to think about this question from a scientific point of view and say, well, the problem with that whole field of interest, and many people say to the Institute, why aren't you interested in this phenomena? And our answer is, it's not a testable phenomena. There's the best we can do is look at images or video clips and maybe try to evaluate them, but we can't test hypotheses. We can't apply the scientific method to do any really hardcore research to investigate. And so those kinds of inquiries we leave for people who are interested in that kind of thing and follow. But when you think about it, practically speaking, our closest neighbor star is Alpha Centauri. It's 4.2 light years away. The New Horizons spacecraft is a spacecraft us humans built that was sent to investigate Pluto and arrived in Pluto after a 9-year journey in 2015 and took all those amazing, wonderful, incredible pictures.
At what speed?
And it was traveling at 40,000 miles an hour.
Okay?
And if you sent that spacecraft to Alpha Centauri at 4.2 light years away, it would take 17,000 years to get there, which is 3.5, 4 times, recorded human history. I mean, so
yeah, it's a problem.
It's a problem. So the scales are vast, and I think, an obvious answer is, well, clearly they have technology that, we have yet to imagine, and that's why they're here. Okay, that's possible. But, also sending biology over such vast time horizons. I mean, even if you have the ability to travel at fractional light speed, the acceleration process and the deceleration process, the novel of the three-body problem with the Solarians, who in fact come from, this nearby planetary system, Alpha Centauri. They have fractional light speed technology, but they talk about coming to Earth and taking 500 years to do it. So, biology, any kind of biology that we know or can imagine, doesn't have that kind of a lifespan. So you're talking about multi-generational spacecraft. You're talking about something that has to be rather massive to provide the life support systems and the infrastructure to maintain such a group. So then you can say, well, what about, mechanical probes and things of that sort? That's maybe more reasonable. But I don't know, tiny little things darting about our skies, being that kind of evidence, it's just difficult. So, it's just one of those things where we start thinking about, just the sheer scale of the universe, which is so hard for us humans to grasp and get our head around, that, we just say it's an intriguing and enticing possibility. We're not qualified to rule it out and nor discourage it if people want to hold that belief. But we do feel that it's important to at least point out some of the challenges involved in the idea that we've been visited.
So suffice it to say, you don't believe in Area 51 or secret government records or anything along those lines? Because I happened to just read yesterday, former President Obama was on with James Corden, and they were joking about how when he got into office, the first thing he did was to look at the secret records to see if there was anything about aliens, which he discovered that there was not.
Yeah.
But he said there are UFOs, whatever they are.
Yes.
Okay, but you're basically saying it's scientifically untenable, as far as you understand, to bridge that gap and therefore we shouldn't have expected any visitation at this point.
Yeah, now, I mean, there's really interesting ideas, such as, you talk about a civilization so advanced that, maybe they've had the technology to, bounce around the cosmos and seed life on different planets that might be habitable. Interesting idea, but there's certainly no evidence in, recorded human history, for example, or in the fossil record, that would indicate anything sort of unusual other than sort of the normal evolutionary processes we've all been studying, on this planet for now that go back billions of years to suggest, some sort of intervention or visitation. People like to point to some of the engineering marvels like the pyramids and other things and say, well, how could those have been built by primitive peoples? And I guess my answer would be, if you have the technology to travel to Earth from wherever you came from, you're probably going to build something other than, made of something other than stone for a starter. You're going to have the technology to do some incredible advanced materials work that, we wouldn't even recognize today. So, these notions are intriguing and fun and so forth. And but yeah, not hard science from our perspective.
Okay, so now I want to ask you a slightly harder question, maybe. I read Contact by Carl Sagan probably in '85 or '86 when it came out, and I found it to be so compelling and so fascinating, as so many people did. Everything that he did was held in great esteem. And he, I think, he had a book called The Pale Blue Dot, if I'm not mistaken.
Absolutely.
Okay, so if our producer could put up the famous picture of the pale blue dot for one moment.
Yeah, it's a beautiful.
Let's see, Mr. Producer, you got that blue dot? There you go.
Yeah.
Okay, so that is a picture, probably the most remarkable picture ever taken of planet Earth. I'm not sure the distance at which it's taken, but I think it's tens of millions of miles. Is that correct?
Oh, yes. I mean, so his idea was that I believe that original pale blue dot, because a more recent one was taken by the Cassini spacecraft out by Saturn. I believe, if I'm not mistaken, but my memory isn't all that good, is that it was the Voyager spacecraft that took the original pale blue dot photograph. And it was Carl Sagan's idea, as the spacecraft was, traveling towards the outer planets of our solar system. And Carl Sagan said to NASA, why don't you turn the spacecraft around and aim the cameras back towards Earth and take a picture so we can all see what our little planet looks like from just that, relatively close by location. And and NASA agreed, and they took this picture, which has been, become one of the most iconic, pictures in astrophotography ever. And then Carl Sagan wrote this beautiful and moving piece about, everybody you ever knew, every king, every queen, every crook, every hero, lived and died and evolved and thrived or not, or suffered on this tiny little pale blue dot. And
it's astounding.
In perspective, it puts our place in the universe in perspective, and it reminds us that, we are truly on an island. We're on a small, insignificant planet on the edge of an insignificant galaxy, which is one of hundreds of billions of other galaxies. And it's like, wow, that's quite a perspective.
It is. And I think just staring at that picture, I think that one could have one of two. There you go. There's the quote. You could have one of two reactions, it seems to me. Like, one is maybe, as you said, like, wow, we are just alone? And it does seem somewhat insignificant when you consider the scale.
Yeah.
Right. And it's almost impossible to wrap your head around the scale. And what we just saw was a micro fraction of a portion of the whole thing, which your mind can't even encompass, right?
Right.
So, without taking us in any type of silly direction, I'd like to use an example from the Hitchhiker's Guide to the Galaxy, which is how I think of it when I see this picture. And you tell me, I'd like to inquire what you think of it. But did you read the book?
I have, yeah, but a long time ago. So go ahead.
Okay, so there's they built this machine called the Total Perspective Vortex.
Mhm.
and it was used as a torture device. And the way it worked was it showed you in proportion to the rest of the actual universe. And the person who would experience it in its totality would feel so utterly insignificant that I don't know, they would suffer or die. I don't remember exactly
Yeah.
what happened.
Yeah.
So they put one of the main characters, Zaphod Beeblebrox, into this total perspective vortex, and he came out delighted and excited. And the reason is because he was the king of the universe, and so it gave him the total perspective on what he was in charge of, and therefore he found it delightful. So, does one have to have a negative reaction? Does one have to feel insignificant as a result of having that perspective, or can it be the opposite? Can it be this? How magnificent that we are here by ourselves on this dot, doing what we do, trying to do good and be good and change the world and have our relationships we're in this wondrous process and how wonderful it is as opposed to how bleak maybe.
Yeah. Oh, I agree. I mean, and when I say, insignificant, I guess I mean this in the context of in space time, we are an insignificant blip, but to ourselves, to each other, we're surely not. But one of the perspectives that I think it provides us with is I think a positive one, which is take a look at this tiny dot and appreciate that's where we all are. We're all in this together, and we don't behave that way. We don't behave like we're all in this island together. But I think for me, the hopeful perspective that comes out of this image is this notion that we are all on an island. We're all sharing some real estate on this tiny little space. We should be working together, cooperating together, cherishing this tiny pale blue dot because it's the only one we have. And by the way, there's no good plan B for Earth.
Right.
We have significant challenges facing us. Mars is not a plan B. Alpha Centauri is not a plan B. We don't have a plan B. So if we can all work together to make plan A sustainable, then we have a long-term future. And if we can't, then that's not so good. But I like that perspective, that it's a reminder not of how insignificant we are and therefore who cares, but rather, look at this, tiny island that we all share together. Shouldn't we, be acting as one cooperative species on this planet and doing the best we can to take care of it?
I wasn't going to ask this, but now you brought it up. Do you believe in the SpaceX project? Do you think that we should try to colonize Mars, or is that a not a good use of time and resources?
Well, I don't know that it's a good use of time and resources to colonize Mars. And of course, colonization now has all kinds of negative connotations associated with it based on human colonization on our own planet and how, the civilizations that have been visited by the colonizers have usually not fared very well.
Right.
I think, so going to Mars for the sake of establishing colonies, it's like, well, why? I mean, first of all, it's not a very pleasant place to live. As I think it was Elton John who said, it's not a great place to raise your kids. It's a very, very harsh and dangerous environment. You have to build and live within a habitat. And when you're not in that habitat, you have to be in a pressurized spacesuit. And we're not going to terraform Mars to make it Earth-like anytime soon. It doesn't have a magnetic field. There's no shielding towards cosmic rays and, deadly radiation that pretty much kills everything on the surface of the planet. And but going there to do science, oh, absolutely. There you don't need a huge facility to do that. And I think there are advantages to sending humans to Mars to do science because we can do things that machines can't do. So I believe in that, but I don't necessarily support the idea of going to colonize it. And interestingly, there's a whole area that NASA is very much involved in and a proponent of, and it's an area called planetary protection. And the Planetary Protection Department at NASA has two aims. One aim is to prevent forward contamination, meaning not bringing harmful, contaminating things to other worlds that we visit. And it also is concerned with backward contamination, which is making sure any samples of material we bring from some other place, don't have harmful elements within them that can do us harm. And so from a planetary protection standpoint as well, we look at Mars and say, we shouldn't go and contaminate, this ecosystem, whatever it may be. But that's not to say that it's not an interesting place to go visit and learn about and understand. And of course, if we find evidence of life on Mars, which is very possible, probably not on the surface for the reasons I just stated, but could be below the surface, most likely microbial if it exists. But there's water on Mars, and Mars was an ocean world in its early days. But that would be significant, because that would begin to indicate that life as a phenomena may be as natural and common a phenomena as the formation of planets, which we now know are ubiquitous. We now know, thanks to the Kepler mission and other projects, that planets are everywhere. They outnumber the stars, and that tens of billions of planets in our own galaxy are planets which we know to be rocky, Earth-like planets in the so-called habitable zone of their star, where the conditions are right, in theory, for life to happen. And if we found evidence of life with unique biogenesis on more than one place in our own solar system, the implications would be game over. Life is everywhere. That doesn't mean it's easy to find. It doesn't necessarily mean it's evolved to a technological level that we can, communicate with or interact with necessarily, but it still has profound implications, I think.
Okay, so at SETI, you've been waiting a long time for a signal. I think that's the right word. Is it 50 years, 60 years at this point?
The SETI as an endeavor started, the first SETI project was undertaken by Frank Drake, who was one of the first CEOs of the Institute here. He was also the director at the Arecibo Observatory for a number of years. He's still with us and lives here in the Bay Area, although retired. But he did the first SETI radio search back in 1960. And but it wouldn't be correct to say that we have continuously been scanning all the sky. I mean, if you really wanted to undertake a comprehensive SETI search, you would have radio telescopes all over our planet, pointing to every possible direction of the sky, highly sensitive, with tuners like radio receivers that covered a wide frequency range, so that if ET was broadcasting on any particular frequency, you'd be able to pick it up. And you'd be doing this 24 hours a day, 7 days a week. And we've never been anywhere even remotely close to this. So one of the ways we like to express, how much have we searched when people ask? The answer is, if you go to the ocean and you dip a measuring cup in the ocean and you take that out and you now say, okay, I want to understand everything I can about the oceans from this cup of water. I mean, that's, relatively speaking, how much we've looked at, and probably not even that much. We've been looking for 50 years, yes, but across all frequencies and all kinds of possibilities and in every direction, no. 24/7, no. And so there's been good reasons to. This is the Very Large Array in New Mexico. It's on the screen here. And we've actually announced a project with the National Radio Astronomy Observatory that manage the Very Large Array to do what's called commensal SETI, where the Very Large Array, which is used to do cosmological and astrophysical observations, is operating more or less 24 hours a day, 7 days a week, but doing different kinds of research and pointing in different directions based on the primary science objective. We've now reached an agreement with them where we're building the back-end fiber optic technology to take the entire field of view of the array, whatever it's looking at. So the array is going to be looking at some sort of point phenomena in space, but it's going to be capturing a bigger field of view. We're going to capture the radio signature of that entire field of view and process those signals. And it may be, I think, one of the most comprehensive SETI endeavors ever undertaken, because it will be with a highly sensitive instrument, and it will be 24 hours a day, 7 days a week. And so that's extraordinary. We've never done anything like it. But there are other, instruments that get chunks of time and look in a piece, a section of sky. but we've not, as a civilization, ever done what I would consider to be a truly comprehensive search.
Is that because of budgetary limitations or technological
Mostly,
challenges?
I mean, certainly the technological challenges. I mean, one thing that is important to realize is that, for example, our planet, we have been emitting electromagnetic radiation into, you know, the skies for now 100 years. So you could go back to the invention of the radio about 100 years ago. So some might say that we are, as a technological civilization, we're only 100 years old. And so our signal has now traveled through the cosmos 100 years. So somebody 100 light years. So a civilization less than or equal to 100 light years away from us could, in principle, see our signals. But again, a fun way to think about the scale here is our galaxy is 100,000 light years across, just our galaxy. And we're talking about going out only 100 years. But in any case, our signal is very, very weak. It's broadcast in all directions. It's not a high energy source being pointed at a particular direction. And so, for example, the radio telescopes we have on Earth would not be capable of detecting an Earth-like planet emitting Earth-like radio signals from anything more than, say, 10 light years away or so. And so part of the theory, if you will, or the search principle behind SETI as an endeavor is, well, you know, certain advanced civilizations may have gotten to the point where they are actually intentionally directing higher energy, focused, you know, radio signals. They could be coming towards us on purpose. They could be, you know, we might just be accidentally on the line of sight of some, you know, very long distance communication that's happening with high energy. But it is fair to say that, you know, we don't yet have instruments sensitive enough to just detect sort of the technological civilization's leakage of material into space. So that's another reality. So technology is one part, yes. Funding is another part. NASA funded SETI programs up until 1992, and then there was a Senator Byrd, I think it was, who felt this wasn't a good use of government funds, and NASA stopped funding it. I think within 2 years that was overturned, but NASA never got back into the business. NASA is now, for the first time in decades, beginning to look back and start thinking that, well, actually looking for technosignatures, of which SETI and radio signals is just one type of you know, technological signature. Lasers would be another, for example. Observations of you know, planetary environments that look like somebody's been messing with them would be another. So there's lots of different technosignatures. NASA is now beginning to start doing small amounts of funding for technosignature search. I think for many reasons, because NASA, with its Kepler mission, learned and proved that planets are everywhere. You know, so now there's sort of an imperative to really go after this question: are we alone in the universe? And interestingly, there are 3 science questions that NASA has. The first one is, how does the universe work? The second one is, how did we get here? And the third one is, are we alone? And so it stands to reason that NASA should be funding, you know, SETI endeavors, as well as more, you know, conventional astrobiology, like sending a rover to Mars. And they're starting to again. So we'll see if that funding environment changes in the coming years. But back to your question, yes, funding has been a limitation for sure. Technology has been a limitation as well. So
the question I was originally going to ask, which I think I know the answer to, but, you know, given that it's been however 50 years, with the limitations of the ability to scan in the way that you really would like to, your website refers to this as the great silence. You know, you're looking and you're listening, you know, and so my question is, are there ever days that you wake up and say to yourself, like, you know, what are we doing this for? You're like, do you ever just say, like, you know, let's just pack it up, you know, it's we've tried, we gave it a good shot, you know, but it's not happening, and let's do something else.
Yeah.
You ever feel that way?
No, never. Well, first of all, because, you know, our work spans a lot more science than purely SETI research. You know, we're part of NASA missions. We're part of the Perseverance mission. We were part of the Curiosity mission. We We ran the what was called the Hazard Avoidance Team for the New Horizons mission. We're on the OSIRIS-REx sample return mission. One of our scientists is waiting for the material from asteroid Bennu to come back in 2023 and analyze it. He's on that team. So we do lots of different things, and even from our point of view, the discovery of microbial life, or the evidence in a so-called biosignature, for example, looking at the spectrum of the atmosphere of a distant planet and discovering things like oxygen and methane in that atmosphere might suggest, the presence of life on that planet. So if we find evidence of even any basic life beyond Earth, I think it's going to be a profound moment for humankind. And where SETI is concerned, looking for technological civilizations, again, from my point of view, we've just begun. It's an interesting exercise to put the history of Earth, which is 4.5 billion years, in the context of 24 hours, right? And if you do that, the human species didn't come around until like 11:59 p.m. and 40 seconds or even more, I forget. But if you start then looking at how long in the course of 1 year have we been using radio telescopes to do SETI endeavors, the answer is a few milliseconds,
Right.
a few thousandths of a second. So, and SETI is an endeavor in space and time. It's not just, where are they or where were they, but also when were they?
Right.
Bear in mind, a signal that we would pick up from a planetary
It's ancient.
50,000 light years from here is 50,000 years ago. So,
Right.
so it's a fascinating question, but no, I think that we've only yet begun and only scratched the surface. And of course, like a lot of basic research things we do and exploration that we do, there's also the tangential benefit, if you will, of the technologies that are developed, which, we're doing some hard, challenging things. The signal processing, for example, to coordinate the field of view of 27 massive radio telescopes and make sense of the data coming out of it is extraordinary. Incredible compute resources are required. Massive amounts of data are processed. So, we do things that contribute, to human engineering and human science and human knowledge, even through the endeavor, and even though, we haven't heard anything yet.
Okay. Let's say tomorrow we did. Let's say the breakthrough came and some detectable signal, I assume would be some kind of mathematical signal that I don't even know what would constitute the right kind of signal to receive, but let's I'm sure you do. What would happen next? And what would it mean? What would it mean to you, and what would it mean for all of us?
Yeah, those are great questions. I would say that, first of all, what would happen next? The immediate thing that would happen next would be that if, for example, it was one of our radio telescopes, our Allen Telescope Array in Northern California, or when we get the VLA project up and running, if it was that instrument, the next step would be we need another observatory to look in that same part of the sky at the same frequency and see if you can find this signal as well. And we'd try to do that like immediately. We would be calling other radio telescope facilities and we say, point your dishes over here and listen, and here's the frequency you want. Because the first thing we always have to ascertain is this signal coming from something local? Is this a spy satellite or a military aircraft or something else, or a microwave oven? So there's a lot of work has to go into making sure that we don't have radio frequency interference. That's why radio telescopes, like optical telescopes, are built high up on mountains, sort of for obvious reasons. Radio telescopes are built in remote areas, far away from sort of electronic noise and interference. So the first step is verify that this is real, and observe it from another point. And if we're triangulating on the same spot, and that same spot is outside of our solar system, well, okay. And then is there something about this signal that we can say distinctly differentiates it from a natural phenomena? That has some structure or some composition or it's narrow band. If we can observe something that nature doesn't do, then we can say, okay, this is technology. We don't know what it says necessarily, and it may not say anything. It may not necessarily be information, but if we can clearly say that's technology, then the next step would be we would probably make the announcement. And people often ask, well, for sure, you're never going to be able to make the announcement. The government's going to come in and shut this down, and tell you can't tell anybody. And that's not true. There's nothing to say that that's going to happen. And I've also joked with people. I've said, look, if you're worried about that, set a bunch of cameras up outside the main entrance of the SETI Institute. And if you ever see a bunch of black Escalades pop out, park in front with guys in suits and earpieces jumping out, then maybe, you were right. Even that, we won't be able to keep a secret. They'll say, aha, they must have found something. So no, we won't keep it a secret. We would certainly tell the world. I like to joke that, I've got this vast hidden power that I can really only use once, which would be to call a press conference. Because if the SETI Institute calls a press conference, pretty much people are going to say, okay, this must be it. So, we would first verify. If we had solid verification, we would announce. We would almost certainly, however, I think, put caveats in there, like we think, we have observed, this is what it looks like, and it certainly suggests ABC, and it needs to be studied further. And, the scientific community will be doing that over the, coming days, weeks, and months. But what does it mean? I think it would really be profound in the extreme. And what, Jill Tarter, who's the co-founder of the Institute, and by the way, was the inspiration for the character played by Jodie Foster in the movie Contact. And Jill is a
good movie. I recommend the movie.
Great movie. And Jill and Jodie, was an advisor to that film. And anyway, wonderful, wonderful movie. But Jill, describes the endeavor as a hopeful endeavor, because one of the things that is statistically true to say is that any civilization we find evidence of is most likely going to be much, much older than we are. The odds are that because we're only 100 years old in terms of technology. So statistically speaking, it's most likely if we find evidence, they could be hundreds or thousands or tens of thousands of years older in terms of being a technological civilization. And if that's the case, and we surmise that any civilization that has taken the same path as we have, growing up from hunter-gatherers to, doing agriculture to developing technology, is also creating problems, harnessing the atom and harnessing pathogens, and having populations grow up that put challenges on resources. If such a civilization survives those challenges and overcomes, these things which are very serious existential, threats, that is a very positive outcome and a very hopeful outcome. It says we can do that too. There's Jill Tarter, and she's wonderful. She's on our board of trustees still, and she's on our science advisory board. She's absolutely amazing. And we have a summer research program that brings early career PhDs to the Institute. And one night on one of those programs, just for a break, we showed the movie Contact to the researchers. And we had Jill here, and she was talking about the movie as it was being shown. And, of course, there are things in it which are quite fantastical and other things which are like mathematically and scientifically totally incorrect. But anyway, he was talking about it. And anyway, after the film was over, I was walking out with one of the young researchers, who was a woman, and I said, "Well, how did you like this movie?" And she said, "Oh, I love this movie. That's why I became an astronomer. That movie inspired me to dedicate my life to astronomy and astrophysics." And I said, "Well, so this must have been really kind of cool for you. It must have been good fun, and to meet Jill and all that." And she stopped and she turned and looked at me and she said, "You have no idea. This was the best moment of my life." Wow. That was powerful. I was definitely moved by her statement. But anyway.
Okay, so it's hard. Obviously, you can't disagree that it probably would be one of the most profound moments in human history to confirm the existence of life beyond our own. Let me pivot, and this is the area of our conversation where you assured us that you didn't have any expertise in. We are people interested in a metaphysical as well as a physical existence. Sure. We talk to people on both levels. We're not asking anyone to believe anything particularly, but we certainly in the last few weeks have had very fascinating conversations with some great physicists and wonderful people who do not believe particularly in anything that can't be measured and seen. But do you mind if I ask you, do you have a spiritual life? I don't mean to pry or ask you any personal questions, but is that part of your consideration at all? And then I'll springboard off of that into my next question.
Yeah, well, it's an interesting question. I would say that I certainly have some spiritual beliefs and considerations, and I think, for example, ancient peoples and indigenous peoples have a lot they can teach us in these areas. I would say my thoughts along those lines tend to be more spiritual than they are religious. That sometimes I struggle with our different religious perspectives, but I can find myself walking a trail along the California coast on a beautiful sunset night with these empty, gorgeous beaches below, and you look at this scene and it's moving. And I don't necessarily understand why it's moving or what about it is, but I can only describe it as a spiritual moment for sure. And there are people at the Institute with very fascinating beliefs in this arena, not necessarily about, say, deities per se, but about is the universe a consciousness? Is there a construct to this massive trillions of galaxies? That is it live in some way? Does it have a consciousness?
Consciousness, right?
Right. So these are really fascinating questions, and we do have people here who ponder them. We also have an artist in residence program at the Institute, which allows artists to work with our scientists and interpret what they're doing in interesting ways. And they get into all kinds of really interesting conversations and thoughts experiments. And we are, doing more to say that, we'd like the Institute, if nothing else, to be a place where these kinds of conversations happen. We're not going to become anything akin to, a religious or spiritual organization, but be open to, these like metaphysical as well as physical aspects of our existence. And, what do they mean? And what can they teach us? And what implications do they have? So, these are also very fun and interesting questions and philosophical questions. And, even things like, should we go and inhabit Mars at some level? These also become cultural and philosophical and spiritual questions, not just purely, hardware-based scientific questions.
Yes, I really appreciate your description of the appreciation of walking on the beach and having what I think is a universal experience of, without being able to put your finger on it or necessarily be able to articulate it very well, not you, but I mean all of us.
Yeah.
That there are certain moments that seem to give rise to a feeling of being part of something that's beyond oneself.
Absolutely.
However you want to ascribe that. Some people call it a higher power. Some people call it the universe. Some people call it consciousness. Whatever it is, I do think it's a universal experience. And the more I speak to scientists, and like I said, I've been strangely privileged to speak to some very great scientists in the last few months, and I find that when you push a little bit, or in a gentle way, that they do seem to we share something similar, which at very least is an awe and a wonder for creation. Creation is a loaded word, but for the universe.
Yeah.
And trying to ponder the ultimate meaning. Like I introduced this show as being about meaning and in the search for meaning and integrity.
Yes.
Which is what I believe that I think that's what we're all doing. And I think that's what SETI does. I think that's what you're involved in. And it's a beautiful feeling, I feel, to participate in it. And I think you're very fortunate to have the position that you do and to be able to so directly embark on this search, and which is probing like some of the foundational elements of the universe. It's wild. Yeah. And I would expect that there would be a kind of reverence for that, which again could be labeled in a variety of different ways. But I thank you for your honesty and your openness in discussing it. But you had mentioned your reluctance towards a religious approach, which many people say, and I understand it. You know, would you imagine in general that religion, and I know there's many religions, so I have to be general, but you know, religion is, would you say it's supportive, suspicious, or hostile to the idea of aliens in your experience?
Yeah, that's an interesting question. I would say, you know, not necessarily. Well, the history, for example, of the Catholic Church, one could say, was very hostile to the idea that, you know, that anything other than the universe all revolves around us and our planet. You know, any ideas to the contrary were you know, very quickly squashed. So, you know, the early days of the Catholic Church, I would say, were hostile to this question, and perhaps other religions where, you know, as I put it, they weren't so much about, you know, belief in a God or a higher power, but rather how important we are. And therefore everything revolves around us. And if you believe something different, you know, you're not a good person. So, but I think more recently, for the most part, I think religions are more open and supportive. I mean, I think that you know, many different religions also ask these questions, you know, where did we come from? How did we get here? Are we alone? I mean, it's difficult to, you know, look up at a starry sky when you're in like a high altitude place away from city lights. I mean, if you've never done that, I'm sure you have, but you know, people who've grown up in urban places and haven't been like out in the middle of nowhere on a clear starry night, you have no idea what that looks like. And it's one of the most spellbinding, jaw-dropping experiences. I mean, I didn't have it until I was, you know, doing hiking as a young man in Yosemite at 4,000 or 5,000 feet on a starry night with no light pollution around. And I literally, my jaw dropped. It was the most breathtaking scene I had ever laid eyes on. And of course, you know, you can't help but then wonder, wow, you know, are we alone in this massive array of stars, or what's going on? So I think that you know, religions are asking similar questions, maybe from different perspectives and maybe with different motivations, but we're all curious. And I'll tell you something quite interesting is we have a science advisory board at the Institute. These are academicians, research scientists, even authors, and people who are advising us as offering external perspectives on where science is headed and where's the funding going, and, you know, what are the things we should be watching. One of our science advisory board members is the Vatican astronomer. His name is Brother Guy Consolmagno. He's an MIT educated PhD astrophysicist, but he's also a Jesuit priest. And he's the Vatican astronomer. That his job is to inform, you know, the church about what's happening in astronomy and cosmology, and it's fascinating. And one of my favorite stories he tells was, and it goes back to a point you made earlier about what unites us as human beings. As a young man, before he joined the priesthood, he was, you know, with his astronomy PhD and wondering if he was doing anything good for the world. There he is. He's just a wonderful, wonderful guy. And he felt, I don't know if this is useful or important, and I'm going to go and explore that question. So he joined the Peace Corps, and he ended up in Africa. I can't remember the specific country, but he was out in the middle of nowhere with young children in this tribal community. And he said, you know what the first thing they asked me was? Of course, we all said, no. What was it? And he said, they all asked me if I brought a telescope. He said, they didn't ask if I brought chocolates or food or candy or radios or skateboards or soccer balls. They asked if I brought a telescope. And he said, it was that moment that I realized I'd been on the right path all along. And that I discovered, he said, in a moment that was a bit of an epiphany, that, you know, it is our curiosity that unites us as human beings. That's what makes us all human, as we are united in our curiosity, in our sense of wonder. And, you know, we all, you know, just about cried. It was such a moving story, but it was so true. And it's really true. And so I like to think that, you know, regardless of what belief system one has or what religious construct one might come from, I think we are all ultimately curious. And we're trying to answer questions, and sometimes through a different lens, and from a different perspective. But we're all asking questions and trying to answer some deeply profound questions very often. And this leads us down lots of different paths, but it's only because we're all curious.
So I'm delighted to hear that I surmise that the Catholic Church has come a long way since its early stance, on this topic. But we come at this from a Judaic vantage point, as you know, and I just wanted, for the benefit of our audience, to read one quote, which I think some people might find, I don't know, maybe surprising, but there's a Dr. David Weintraub, who's a professor of astronomy at Vanderbilt, and the author of Religions and Extraterrestrial Life. How will we deal with it? And there he says that Jewish theology may actually require a belief in extraterrestrials, since there are no limits on the power of the Creator. Thus, for Jews to say that no life beyond the earth could possibly exist would be unacceptable, as such an idea would appear to place shackles on God's creative power. The universe belongs to God, and God can do what God wishes to do with the universe. And there's actually several, I'm not going to go into them, but there are several quite ancient sources, at least in the Judaic tradition, that seem to be in support of the idea of extraterrestrial life, for this reason and for others. And so I would just throw it out to people, anyone out there who thinks that there is some kind of contradiction, that human beings must be the only species, the only life that's in the universe to have significance in the eyes of the Creator, is not necessarily the case. It may very well be. I have no idea. I know that you're quite sure that there is life somewhere, and I'm certainly totally capable of believing that. I'm excited for the day where that could become a reality, and I'm looking forward now to your specific press conference, and those black limos pulling up. But in the interim, I think that it's very important for people to keep their minds open and to remember what it is that we were discussing. The most important part of all this is that we're searching together for what this is all about, what life means, and trying to contribute on a day-to-day basis to improving our lot here as best we can in the interim. And as such, I want to thank you profusely for taking the time to be on the program with us this evening. It means a lot to us. You're a fascinating person, and it really was a pleasure speaking to you. So thank you for being here.
Well, it was a great honor, very, very enjoyable and pleasurable. And next time, we'll have you speak to the smart people at the SETI Institute, and that'll be even more fascinating. But it was great fun and very enjoyable.
All right. Thank you so much. And good evening, everybody from Beyond Belief. See you next time.